The next lab that we'll do will be over density. So this is something we covered a little bit in lab number 2, but now we'll take a closer look at it. So the first thing you'll see when you come to the blackboard, there's a video sort of going over what is density, explaining more about density. Then you'll see the actual lab experiment, the report sheet, a place for you to turn in the report sheet. You'll see the simulator, and we'll talk about this more towards the end of this discussion. And then there's a video about using a balance and about how to find the volume of, or the density of irregular objects. Okay, so first let's take a look at the experiment sheet. Okay, well, this is the report sheet actually. Let's go to the experiment sheet. Okay, so let's go back to the top. And you will find some introduction, of course, and then again the definition of density. So remember, density is just the mass of the substance, and it could be a liquid, a solid, or even a gas if you're able to measure that, over the volume. Okay, so just that simple. So mass over the volume gives you the density. So how much stuff is in how much volume. Okay, and then you can of course rearrange this to find the mass, which will just be the density times the volume, and the volume of the substance, which will be the mass over the density. So those are useful if you know the density of an object or of a substance, and you maybe want to find how much mass a particular volume would have, or how much volume a particular mass should have. Okay, then down below that you'll find some regular shaped solids, which have simple formulas. Okay, so something like, for instance, a cube, we know that the volume will be the length times the width times the height. Volume of a cylinder, which you did in a previous lab, pi r squared times the height. Okay, but when it comes to irregular shaped solids, the best thing to do is actually to use displacement. And so you also looked at this in the previous lab, where you have maybe a graduated cylinder full of a liquid. So you take an initial volume, then you add the object, you take the final volume, and the difference between those, that's known as the displacement, that tells you the volume of that object. So suppose you had something where you couldn't easily calculate the volume based on a simple formula. This is the best way to do it. So if you have, an oddly shaped item, maybe, well, whatever it is. But if it's oddly shaped, this is a better way to find the volume. And then, of course, the mass you can find using a balance. If you know the mass and the volume, you can find the density. Okay, the last thing here you'll find is an experimental procedure. Okay, so it asks you to answer the pre-lab questions, and then ask you to open the density simulation exercise and complete the activity there. So let's go over to the report sheet. Okay, and you'll find some pre-lab questions here. So go through those and answer those. Okay, the next thing you'll get to is this simulation activity. And so the first one, what it does is it asks you just to play around with the simulation. And I kind of want to just show you a little bit about the simulation now. So the first thing, when you come to the blackboard, if you come down to this density simulation and you just have sort of a gray box, you may need to come up to, it'll say something like, a flash is not detected, something like that. You hit allow, and then if you're in Chrome, you'll see a little puzzle piece appear up here. If you click on that puzzle piece and you go to manage, there'll be an option that says ask before loading flash. So select that option, and then you will want to reload the page. And then when you come down to the simulation and you click on the simulation, another box will pop up and says, do you want to allow this to load? And you can allow that to load. Okay, so but once you have this loaded, so you have a cube, and you can tell it to do different things. So you can kind of toss it around, and you can see if it'll float or not, and you can do a few things. So if you have material selected, okay, you can go to things like styrofoam, brick, okay, or wood is the default where it brings you to. And what you can do is this has a fixed density. So you can see the density 0.40 kilograms per liter. And typically we talk about density in grams per milliliter. That's probably what you're familiar with. But just know that kilograms per liter is equal to milligram or grams per milliliter. So if you multiply both by 1,000, you get to kilograms and you get to liters. Okay, so those are the same. And remember that the density of water is 1. Okay, so that'll be helpful when it's asking you things like, why does something sink or why does something float? So why does something sink in water or why does something float? So if it has a lower density, so like our piece of wood here, so it has a density of 0.4, and whether it's in grams per milliliter or kilograms per liter doesn't make a difference. Again, those are the same unit. It has a lower density than water, which has a density of 1, so it will float. But take a look if we switch this to aluminum, for instance. So now we have a density of 2.7, okay, which is much greater than 1. Okay, so our object sinks. Okay, so that should hopefully give you a little bit of insight and help you when you're trying to determine why something would float in water or whether it will float in water. Okay, and there's some questions in your worksheet asking you about that, but I just kind of want to show you a little bit about how to use the simulator for now. And now I am in the My block, and this allows you to change things like the mass and the volume independently. Okay, so what if I have an object with a very low mass and a very high volume? Notice what happens to my density. So I would have a very low density because I have only a little bit of stuff and a whole lot of space. Okay, what if I have a very low volume and a very high mass? Okay, so that gives me a very high density because I have a whole lot of stuff in a very small space. What if they're equal? So let's try to make these two as equal as we can. What happens to my density? So you'll see I'm close to the density of water. I'm almost, because I'm even, so I essentially have, x over x, or in other words, 1. Okay, so what if I increase the volume a little bit? So now I'm less than dense than water. If I keep increasing, I get less and less dense. Okay, so that kind of is what they want you to do, is just sort of play around with the simulator and see what you can do and see what things you can find. Okay, so it's very open to any question. So see what you can come up with on your own. And then if you click same mass, it will give you several objects that have the same mass but different volumes. Okay, so they'll have different densities, of course. So you can see this one sinks, but the other one floats, and you can even stack them. I think that's kind of fun. So you can stack them on top of each other and just see how this all works. You can also keep the volume the same. Okay, so everything has the same volume, but it has a different mass. Okay, so you can kind of play around with that. You can make everything have the same density. So they'll have different volumes, different masses, but ultimately the same density. And you can see what's happening to the volume of the water as well. Okay, and the last thing is you have mystery. Okay, and this allows you to weigh them. It also allows you to measure their volume by displacement. So notice if I pull it out, the volume of the water goes down. If I add it back in, the volume of the water goes up. Okay, so I could calculate density based on 3.53 kilograms and about 1 liter. Okay, so that's sort of what they're going to ask you to do in the lab report. And so hopefully that's been enough of an overview of the controls that you'll be able to pretty much figure everything out. So hopefully you can get this loaded. If not, let me know if you have some issue with that, and I'll do my best to help you. Let's see. Okay, so I think that pretty much wraps up everything I wanted to tell you about this one. I don't think you'll have too much tough a time with this, but if you do run into any problems, please do let me know. Again, come see me in my office hours or email me at any time, and I'm glad to help you. I will see you next time.